The universe stretches out, full of wonder, full of mystery. Galaxies swirl, stars ignite, planets orbit in silent dance. Earth is one such planet, our home, our sanctuary. But space is not always benign. It holds potential dangers. Asteroids are one such threat, rocks drifting through the void. Some dangers are well known. We track many asteroids, we map their orbits carefully, but some threats remain hidden. They lurk in cosmic shadows. Venus, our planetary neighbor, orbits closer to the Sun. It has companions unseen by us. These are co-orbital asteroids sharing Venus's journey. These companions are hard to spot. They are concealed from Earth. The Sun's intense glare is one reason. It acts like a curtain, hiding what lies beyond or what lies too close to it. Venus itself is bright. Its proximity further complicates. Our telescopes strain to see these elusive space rocks. This hidden cohort is not just a curiosity. Astronomers are cosmic detectives. They scan the skies for clues, searching for objects near Earth. Recently, their attention sharpened. New research has pinpointed specific threats. These are not distant, abstract dangers. They are asteroids with Earth's name potentially written on their future paths. The threat is becoming clearer, and it is alarmingly close. One of these is named 2020 SB, a designation like a case file. This asteroid is a concern. It is one of the Venus co-orbitals, currently hidden from easy view. Its orbit is what worries scientists. It has the potential for trouble. A close approach is possible. A collision cannot be ruled out. We must understand 2020 SB. Two other asteroids share this notoriety. Their names are 524522 and 2020 CL1. Each one is a significant object. Each one travels a precarious path. Like 2020 SB, they are veiled, concealed by sunlight and orbital mechanics. They represent a trio of trouble, a triumvirate of potential doom. Their presence demands our focus. When we talk about asteroid impacts, size is a critical factor. A small pebble burns up harmlessly. A larger rock can cause devastation. The asteroids we now discuss are far from being small pebbles. They are substantial celestial bodies, each one a potential city killer. Their dimensions are alarming. We must grasp their true scale. These specific asteroids measure between 330 and 1,300 feet across. That is roughly 100 to 400 meters. Consider what that means. The smaller end, 330 feet, is like a 30-story building, or the length of a football field. The larger end, 1,300 feet, is comparable to the Empire State Building or a modern super skyscraper. Imagine an object that large, hurtling through space, approaching Earth at cosmic speeds. This is not a minor event. The energy involved is immense. The potential for destruction is vast. These are not just rocks. An asteroid impact is a release. A sudden violent release of energy. Kinetic energy, motion turned destructive. The bigger the asteroid and the faster it travels, the more energy it unleashes. For these Venus co-orbitals, the numbers are truly staggering. They are hard to comprehend fully, but we must try to understand. Consider the atomic bomb at Hiroshima, a benchmark for destructive power. An impact from one of these asteroids, even one of moderate size, could generate 1,000,000 times more energy, 1,000,000 Hiroshimas, all concentrated in a single event. This is not a localized explosion, it is a cataclysmic release, a force of nature unleashed. What would such an impact do? If it struck land, entire cities would be vaporized in an instant, massive fires would ignite, spreading for hundreds of miles, the sky would darken with debris. If it struck an ocean, it would generate colossal tsunamis, waves hundreds of feet high, crashing into coastlines worldwide. Wobbling worlds, the instability of their paths. The orbits of these asteroids are a key part of their danger. They are classified as co-orbital. This means they share Venus's path, circling the Sun in similar orbits, locked in a kind of gravitational dance. One might think this keeps them far safe from Earth's vicinity. But the cosmos is complex. Their paths are not truly stable. Co-orbital does not mean fixed. It does not mean perpetually safe. These asteroids, particularly the three identified as 2020 SB 524522 and 2020 CL1, have orbits that are described as unstable. They wobble, they shift, they evolve. Over time, their trajectories can change. Subtle gravitational influences play a role. The pull of Venus, Earth, other planets. These forces can add up. This orbital instability is crucial. It means these asteroids can be nudged, pushed from their current paths. A slight shift in their trajectory caused by these complex interactions could set one on a direct collision course. A collision course with Earth. Blinded by the light, the detection dilemma. Finding these dangerous asteroids is an immense challenge for us. It's not that they are too small, it's where they are located. They are hidden in plain sight, or rather hidden by the brightest object. The sun itself shields them, making them incredibly hard to see from our vantage point on Earth. This is a critical blind spot. The sun's overwhelming glare is the primary problem here. Asteroids orbiting closer to the sun than Earth does, or near Venus, are often lost in this brilliance. Telescopes on Earth must look in directions close to the sun. This is difficult and dangerous. It is like trying to spot a fly next to a searchlight. Even our most advanced facilities struggle with this specific task. Consider the Vera-C-Rubin Observatory, currently being built in Chile. It will be a powerful survey telescope. Yet for these sun glare-hidden asteroids, it would have limited warning capability. If one were on a collision course, Rubin might only spot it weeks before impact, 2 to 4 weeks. Unveiling the invisible Carruba's cosmic investigation. Science does not stand still. Researchers are actively working, trying to understand these hidden threats, to quantify the risk they pose. Knowledge is the first step, the first line of defense. Recent studies have shed new light, bringing the invisible into sharper focus. This work is vital for our safety. It guides our next actions. A key research effort in this area was led by Valerio Carruba. He is an astronomer at São Paulo University, located in Brazil. His team delved into the problem of Venus's co-orbital asteroids. They sought to understand their behavior, their potential for Earth impact. Their findings are sobering and they call for attention. Their detailed research was published. It appeared in the respected journal Astronomy and Astrophysics. This is where scientists share their most significant discoveries. The study was not based on guesswork. It used sophisticated computer simulations, modeling the long-term evolution of these asteroid orbits, predicting their future paths. These simulations were extensive. They modeled imitation space rocks, following their paths for 36,000 years. A sentinel in space. The need for Venus-Proximate observation. Our current methods are insufficient. Earth-based telescopes have limitations. The sun's glare is a major obstacle. We cannot effectively monitor the entire population of asteroids that orbit interior to Earth or those accompanying Venus. If we want to find these threats, we need a new observational strategy, a change in perspective. The researchers, including Carruba's team, have proposed a clear solution. They argue for a dedicated campaign, an observational program designed specifically to find these hidden rocks. This cannot be done effectively from the surface of our planet. The atmosphere and sun's position will always pose challenges. We must go to space. The ideal mission would be space-based, a telescope sent into orbit, not around Earth necessarily, but perhaps operating near Venus. From such a vantage point, it could look outwards from the sun or survey regions difficult to see. Regions where these potentially hazardous asteroids or PHAs are currently hiding. This would give us a clearer view. Only such a dedicated mission operating closer to the source could hope to map them all, to discover all the invisible PHAs among Venus's co-orbital population. Cosmic Vigilance, a call for preparedness. The message from the cosmos is clear. The threat of asteroid impact is real. It is not confined to movies or distant geological history. It is a contemporary concern. As of May 2025, we know that some threats could be imminent, potentially striking within weeks or months. We cannot afford complacency. The stakes are simply too high. This is a matter of planetary defense, protecting our civilization, protecting our species. The warnings from scientists like Valerio Carruba and his colleagues must be taken seriously. Their research points to a critical gap in our awareness and in our ability to detect danger. This gap needs to be closed. We need to foster greater awareness among the public, among policymakers. Understanding the risk is essential. We also need sustained investment. Investment in science and technology, specifically for space observation and for asteroid characterization.